Okay, guys. So today in class we discussed both types of mirrors: the concave mirror, concave, and then convex mirrors. And the only really difference is like the way it's turned, as opposed to the object. So, but both examples we did in class today were outside of the focal point. So right now we're just gonna go over quickly what happens when they're inside the focal point, and then the 4 homework questions today will just be if basically for each type of mirror, if you have an object outside the focal length and then one in the focal length, what will be the height of the object most likely, and then the orientation. So for a concave mirror, when you are outside the focal point, what we ended up having was an inverted image that was below the axis, or obviously inverted below the axis and smaller. Look in your notes for that. And then if you end up inside the focal point, you end up with a virtual image that is upright on the opposite side of the mirror. Because what will happen is these two lines don't actually cross when you go to the center point and reflect off the mirror. And so you have to extend those lines to the other side. When you're doing convex mirrors, when you're outside the focal point, what happened was you ended up with a small upright image inside the focal point of the other, on the other side. And what happens when you go inside is the exact same thing. So it doesn't really change, but what does happen is like the closer you go, I believe the bigger this image will be compared to this one. It won't ever be bigger than this image, but it will be bigger than it would have been when it was further out. So let's go ahead and give these some numbers. So let's say our focal lengths today are like 6 centimeters. So f equals 6 centimeters. And then we'll say our image or our object is at 4 centimeters. We'll say its height is like 2 centimeters. So if we do that, let's see what we got for 1 divided by 6 minus 1 divided by 4. And what I ended up getting for the image was I got I equals, well, negative 12. So negative 12 meaning it's over here. And so if we wanted to find magnification, we have negative I, which is 12, over our object, which was 4. And that ends up equaling 3. Okay. So we end up with a upright image, hence the positive magnification, and it's virtual because if you draw this ray diagram, you have to use these dashed lines that extend these rays that don't really exist over here. You have to use those to make the image. So virtual, upright, enlarged image. And so the height here would be 6 centimeters for the image. So height of the image would be 6 centimeters. Okay, something pretty simple. So let's do the same measurements here. So actually our focal length is technically over here. So we have 6. So we still have the focal length equals 6 centimeters. And then our object is at 4 centimeters, and once again we can say our height is 2. Do the same thing, except now our focal length is negative because any convex mirrors, or is it concave? I can never remember how to.
You should.
I always forget. I'm pretty sure that this is concave. Is it convex?
Yeah,
I never remember.
Like concave, it's like
That's convex, but which one's negative with the focal length?
This one.
This one?
I know it's this one. When it's facing the opposite side of the object, it's going to be a negative focal
If it
length.
goes into the cave, like that's how I remember it.
You
Like
can make your mnemonics. I don't know how. I just know. I guarantee you this one's negative. So
The focal length is negative?
yeah, the focal length is negative. So basically, it's whichever side is inside. So if you drew this whole entire circle out, like the whole sphere, the radius, whichever side the radius is on, that is the side. That's the side the focal length's on. If that is on the opposite side of the object, then you have a negative focal length. Okay, so you can see that this would make a circle, something like that, and so it would have a negative focal length because it is on the other side of the object. So light is shining from this side, so it is a negative focal length. Okay. So make sure you use negative, so 1 divided by 4, 1 divided by 6, 1 divided by 4. And I ended up with, an image that was like negative 2.4, something like that.
Yeah.
Right, okay, so that means negative, meaning it's on the other side of this object. Same thing over there, the image, negative signifying that it's on the opposite side of this mirror, so negative 2.4 centimeters. And then if we want magnification, do that negative 2.4 over 4. And you end up with 0.6 centimeters. So once again, positive, or not centimeters ones, sorry. Not centimeters, it should have no label. 0.6. And that it's positive once again because it's upright. And so this is once again upright, virtual, and we found that it's 0.6 the size, so image height is 0.6 times 2, which is 1.2, so 1.2 centimeters, so smaller.
You have a question.
Yes?
Why in class today was, when we did the concave, that big cross down below, but that one is
Because,
crossing up there?
yeah, because this is inside the focal length. So if it's outside the focal length, it'll cross over on the left side. But for this one, it'll always cross on the right side, and no matter if it's on the right or the left of the focal length, or inside or outside the focal length. Okay? Does that make sense to everybody? Should I run through it again, or should I just leave it at that?
So that kind will always be virtual.
Yeah, this kind's always virtual. Always virtual, and it's always smaller, and it's always upright. Yeah, it's basically it's always this. It always looks something like this. The size just depends on how far away from the mirror it is. The further away it is, the smaller the image. We can do some calculations to figure that out if you want. Yeah.
Where did that virtual line that's coming in from the top?
This one?
Yeah.
So this is the ray of light coming from the top here, and it reflects up, and then this one reflects down. So obviously they're not going to cross. So yeah, both this is going down here, and this is going from there. Okay. Cool. Any other questions? Or are we all good? Okay.